Okay, so starting the Chapter 1 review for limits. Notice this first problem is a limit problem where it just asks us to find the limit as x approaches 2 for 3x squared plus 5. Remember, our first step is always to see if you can just plug it in, because if plugging in works, then you're done and you don't need to do anything more complicated. So with this, if we try to take this limit, after we have plugged in the 2, you no longer need the limit in the front. But before that, you have to write the limit every single time. Since the first step is plugging in the 2, we can just write 3 times 2 squared plus 5. Whenever you're squaring something, it's a good idea to put what you're squaring in parentheses, because a lot of times people will make a mistake if there's a negative in the front, or they might try to multiply the 3 and 2 first before you square. So be careful with your order of operations. So that would give us 3 times 4 plus 5, which is going to work out and give us a number answer. So we have 12 plus 5, so our final answer is 17. And that's it for that problem. All we had to do was plug in and follow order of operations. For this next problem, we have a piecewise function, and it has 2 parts. The first part says find the limit as x approaches 1 of f of x if we have these 2 things. So remember, when we're finding a limit of a piecewise function, we have to split that up into 2 parts. So to find the limit as x approaches 1 of f of x, that will become each sided limit separately. The limit as x approaches 1 from the left, and the limit as x approaches 1 from the right of our function. So we look at our piecewise function, and if we're looking at the left, which is that top limit, then we need to decide the first line or the second line when we're looking at the left. Remember, left means smaller. So according to these inequalities, and in this case, we don't have like a greater than or less than. However, we have a not equal to 1 and an equal to 1. Well, we don't want to look exactly at 1. For a limit, we're always looking at either side. So the one that's not equal is the one that we're going to look at. That's our only other choice. So that's what we're going to use. We're going to find the limit as x approaches 1 of 3 minus x. So then we plug in the 1. 3 minus 1 is 2. Then, to find the other limit, we're looking at the right, which means larger. But in this case, we don't have a larger and a smaller. We just have a not 1. So again, we will use the first line because we don't want at 1, and that's our only other choice, is to choose not at 1. And that's what we're talking about limits. We're talking about on either side. So that's what we use. So again, this means that we're finding the limit as x approaches 1 of 3 minus x, and it gives us the same thing. So that limit, so the limit as x approaches 1 of f of x is equal to 2. Looking at the second part of this equation, explain why f is not continuous at x equals 1. So remember, this is writing out, so we have to write down our reason. Well, we have 3 rules for continuity. 1, we have to have a limit. 2, we have to have a point. 3, the limit and the point have to be equal to each other. So we do have a limit. We just found the limit. It's 2. We do have a point. At x equals 1, our function is 1. However, 2 and 1 are not the same. So this is not continuous because the limit as x approaches 1 of our function does not equal f of 1. So it breaks our third rule, and that's how we write that out. Okay. Also, if you were in class, I forgot to write some infinite limit problems on this review, so that's not helpful because they are on your test. So the 3 problems that I had you write down, are 1. So A, the limit as x approaches infinity of 9x cubed plus 3 over x squared minus 2x cubed. So this is approaching infinity. We have rules for this, okay? So remember, what we get to do is we get to look for the highest exponent on the top and the highest exponent on the bottom. So that's this term. Be careful, x squared is not the highest one on the bottom. Minus 2x cubed is the highest one. So we compare those exponents. Well, the exponents are 3 and 3. They are the same. When exponents are the same and we're finding a limit as x approaches infinity, then we just take the coefficients, 9 over negative 2. And that's it. That's your answer. Then B, the second one I had you write down, was the limit as x approaches infinity for 5x plus 2x squared divided by 4x plus 1. So this time when we're looking for the highest exponent, on the top it is second, and on the bottom it's first. 4x, that's the highest exponent of x that we have. So we have an exponent of 2 and we have an exponent of 1. That means that the exponent is higher on the top. Whenever an exponent is higher on the top, our rule says that the limit doesn't exist every single time. That's it. That's all you have to do. You just have to know the rules and be able to apply them. You can do other work. You can figure it out another way, but it's so much easier just to learn the rule because that takes 2 seconds. Actually solving out, dividing the top and the bottom, that takes a lot of time. The last one is the limit as x approaches negative infinity of 2x squared plus 3x divided by x cubed plus x squared plus 1. So again, we look for the highest term on the top and the bottom. Well, on the top, it's the x squared term. On the bottom, it's the x cubed term. This time they are both in the front. That's nice. They aren't always, but when they are, we'll take it. So we compare these exponents. The larger one now is on the bottom. Whenever the larger one is on the bottom, that limit will equal to 0. And those are our 3 answers for those 3 infinite limits. And that's it for these sets of problems.